Good afternoon and welcome to our presentation on the processing services offered by Hosokawa Micron. My name is Rob Voorhees and I will be your presenter today. Today's presentation will be focused on the size reduction services that we can provide to you. Hosokawa Custom Processing Services made a major investment in a new facility dedicated to providing our customers with state-of-the-art processing services. In 2021, we initiated a search to find a new location for our processing business as we were running out of space at our New Jersey location for future expansion. After an extended search throughout several states, we settled on a site in Goldsboro, North Carolina. This is a view of our brand new facility in Goldsboro, which started full-scale processing services in April of 2024. During the presentation, I may alternately refer to the company as HCPS. The new facility is uniquely suited for our processing business. This 50,000 square foot building sits on 19 acres of land in the Park East Industrial Park located in Goldsboro, North Carolina. We relocated several processing systems from our plant in New Jersey, and we have made substantial investments in new equipment to expand our processing capabilities. The major portion of the facility space is dedicated to various processing systems, warehouse space, and future systems installation. We now have 11 installed systems available to our customers for a variety of processing services, which include size reduction, granulation, compaction, blending, screening, packaging, and powder analysis. This is a partial view of the processing area at Hosokawa Custom Processing Services. In the foreground are 3 systems for size reduction and micronization. Further in the background are additional systems for providing size reduction, blending, and screening operations. A separate area is dedicated to recycling and granulation. Each installed system has its own nuisance dust collection points at specific locations to ensure a dust-free and clean processing environment. All systems are designed for the processing of high KSD value materials, and each system is protected by a suppression system designed to prevent dust explosions related to the processing of organic materials or other chemicals that are potential hazards. The Goldsboro, North Carolina location was chosen for several reasons. However, the most important was access for our customers. Over the last decade, the southeast sector of the United States has had the largest growth in the country for companies establishing new businesses and manufacturing facilities. In addition, many companies have relocated to the Southeast, and in particular North and South Carolina, due to the many benefits and quality of life opportunities these states have to offer. Principal among them is a strong labor force and an overall lower cost to do business. Hosokawa Custom Processing Services is strategically located in close proximity to the major north-south corridor of Interstate Route I-95. We are also 1 hour from Raleigh International Airport with access to domestic and international destinations, and the major seaport of Wilmington, North Carolina is 90 miles to the southeast of Goldsboro for the import or export of materials from our international customers. HCPS offers a range of services for the processing of chemical, mineral, and polymer materials. The services we offer include several different types of size reduction technologies, screening, blending, compaction, packaging, particle size analysis, and particle characteristic analysis. We conduct feasibility testing to ensure we can meet the specifications, quality, and quantity of the finished product you require. When customers are ready to commit to large-scale orders, we then process the materials at our Goldsboro facility. John McGovern is the manager of the business and has over 35 years of experience in the industry. Frank McGowan, the on-site manager at HCPS, has over 20 years of process and operational experience with the processing systems at HCPS. We have a staff of 12 technicians and 2 maintenance personnel, and we currently operate 2 shifts, 5 or 6 days a week. In part 1 of this series of presentations, we will explore the size reduction services that we offer at HCPS. Listed here are the 5 different types of size reduction systems we have available at our new facility in North Carolina. Currently, we can provide services for granulation, hammer milling, attrition milling, air classification milling, and jet milling. In future webinars, we will introduce the other processing services that we have to offer. There are several methods of size reduction that can be selected for an application, based on the materials to be processed and its particular characteristics. At HCPS, we have size reduction systems that operate under different principles of comminution, including shearing, attrition, and impact forces. Based on the material, the end product fineness required, and the application, we select the technology that will provide the most efficient and economical processing of your materials. Let's talk about these three types of size reduction mechanisms now. Shearing is defined as cutting or cleaving a particle in two with a sharp blade. This grinding principle is most commonly applied in rotary cutting machines called granulators, and in vertical cutting machines known as guillotines. Shearing action is often required to process materials that are elastic, pliable, or fibrous in nature. Examples are rubber, plastic, and copper cable, plastic film, and copper cable. The end result is a relatively coarse particle size. Attrition is another method of size reduction. Attrition milling is defined as two particles abrading against each other in opposite parallel planes, with a motive force generated by rotating disks. Materials that don't fracture easily by impact can be processed using this principle. This grinding principle is used in attrition mills and gap mills. Common applications include the reduction of various plastics like PVC or polyethylene when much finer particle sizes are required compared to granulation. More common is the size reduction method using the principle of impact. Impact is probably the most common size reduction method employed in milling equipment today. Impact is defined as a solid object moving at high velocity coming into contact with a stationary particle. The impact principle is employed in three of the machine types we'll review today: hammer mills, air classifier mills, and jet mills. Impact is used to achieve the highest fineness possible in these types of machines. Most hard, crystalline, and amorphous particles react well to impact for the purpose of size reduction. So how do we select the system that is best suited to provide you with the optimal results for your application? In almost all cases, we will request to do a small-scale test to ensure that we can meet your specifications and volume requirements and to determine the appropriate selection of equipment for processing your material. To make sure we select the right processing technology for your application, we look at a number of material factors that affect performance. Material feed size will affect milling performance. Larger feed material means more residence time in the mill system to achieve the particle distribution you require. Larger equipment may be required for a given production capacity. Feed size affects feeding mechanisms and feeder selections. For example, air conveying large particle size, high bulk density material to a mill may not be possible, and alternate feeding devices may have to be employed. Bulk density has an effect on milling performance. Bulk density affects flowability of the product. Feeding can also be affected. Light density materials may flood past the feeding device, affecting feeding accuracy. We use analytical methods available to determine the flood and flow characteristics of your materials. Light bulk density material may affect grinding efficiency, as lighter materials are more difficult to keep in the impact zone of some mills. Cohesive products can cause numerous problems in a milling system. Cohesive and sticky products may build up on mill internals and increase the pressure drop across the mill and affect airflow. Systems may require the use of high-velocity air or special surface finishers to keep mill internals clean. In addition, conditioned air for temperature or humidity control may also be required. Heat-sensitive products also require special handling or special system designs. Low melt point materials are sensitive to mill systems with high energy input. Heat-sensitive products may require cooling of the process air in order to efficiently process them. Product moisture and products with moisture-absorbing characteristics can be problematic when processing. Hygroscopic materials absorb moisture, causing buildup and plugging, and may require dehumidified air for processing. On the other hand, products containing moisture may allow for high-energy processing of heat-sensitive materials. The moisture in the product will absorb the heat of grinding, providing cooling in the process. Material hardness also needs to be taken into consideration. High energy milling may be required to effectively break very hard particles. Material hardness may lead to high component wear and an increased processing cost due to the increased parts consumption and maintenance. Special wear protection of mill components may need to be considered. Fluidized bed jet mills are particularly suitable for grinding hard and abrasive materials. Friable materials or materials that fracture easily require other considerations. High energy input can lead to too many fines generation when processing very friable materials. Low energy processing with alternate mill components may have to be employed when handling these types of materials. If particle shape is important, keep in mind that impact tends to produce sharp angular particles. Compression and shear forces tend to produce more rounded particles, and high aspect ratio materials are damaged by impact forces. As you can see, material characteristics play a very large role in machine and system selection. Our services are focused on processing materials for the chemical, mineral, and polymer industries. With multiple systems, we have many processing options and the ability to handle materials with many different characteristics. With both small-scale and large-scale systems, we can accommodate all quantities of materials. However, our service provides the best economic efficiency when handling projects in the 10,000 to 100,000 pound range per processing run. Let's look at some examples of size reduction systems and the materials we can process for you. HCPS has heavy-duty granulator systems for recycling and granulator applications. The cutting chamber, rotor, and drive assembly are designed to provide maximum rigidity, allowing close knife settings. Our double-angle cut design provides for very tight knife gaps for those tough-to-cut materials like film, rubber, and elastomeric materials. A granulator is ideal for heat-sensitive materials as it runs much cooler than most other size reduction machines and produces a very uniform and clean product with minimal dust generation. For a product that requires nearly zero dust, or if you have light contamination such as paper or film, our dedusting system, which is part of the granulator evacuation system, can easily achieve the cleanest regrind possible. Shown here is a typical granulation system. A process fan provides air to convey ground material away from the granulator. A cyclone provides for the separation of the finished product from the airstream, and ultrafines are collected by the fabric filters after the fan. Here you see a cutaway view of a rotary granulator. The machine consists of a cylindrical rotor assembly with knifed edge blades mounted along the axial length of the rotor. In rotation, the blades pass by a stator at zero clearance to generate a shearing force. These machines are used to process bulk materials and film that are difficult to process in impact mills. They produce a relatively large particles down to the size of a 1/4 inch with a relatively narrow particle size distribution. At HCPS, when high production capacities are required, an air-swept discharge system is used to convey the processed material away from the granulator. Listed here are some common materials that are processed on this type of size reduction machine. You can see the application range is very wide and the production capacities for these machines can be very large. HCPS systems capacities range from 1,000 pounds an hour for very tough to grind materials to over 3,000 pounds an hour for PVC and other easily ground materials. The feed hopper of a production scale machine is very large to accommodate various size parts. To control end product top size, screen sizes from 3/16 of an inch to 1 inch in diameter are available. Let's look at one specific application example. When extruding plastic products, production waste with vastly different material properties and shapes are generated. Examples include semi-finished plastic products, profiles, pipes, sheets, purges, and small trimmings. The yield, shape, and properties of the products to be granulated dictate the best suited granulator configuration for the application. HCPS granulator systems can produce end products that vary dependent upon the application. Dust-free granulated products in the 6 to 8 millimeter particle size range are possible with our heavy-duty granulator systems. Attrition milling is done by a high-speed cutting mill designed for the fine size reduction of plastics, polymers, and fibrous materials that do not respond well to other forms of milling. Attrition mills are designed to grind heat-sensitive and soft materials without liquid nitrogen or conditioned air. Size reduction takes place between an adjustable stator disc and a high-speed rotating shearing disc. The fineness of the finished product is dictated by the number of teeth on the discs, the rotational speed of the discs, as well as the gap between the discs. Some applications may require multiple passes of the product through the mill to achieve the highest possible product yield. Oversized material is separated from the product stream by a cyclone, and oversized material is screened and returned to the mill for additional processing. These systems are capable of fine grinding polymers to a D90 of 100 microns or finer, depending upon the material and application. Examples of more common applications include the recycling of PV scrap from pipes, window profiles, and electrical conduit with a product fineness of between 600 to 1200 microns. Another example would be the production of polyethylene powder for rotational molding applications. PE granules are typically ground to a fineness of a D50 less than 300 microns. Listed here are a variety of materials that can be processed on our attrition milling systems. While these milling systems are commonly employed for use in plastics and polymer applications as shown here, attrition mills can also be used for difficult to grind products such as hard or fibrous nutshells and grain hulls. Let's look at a specific application. The use of three-dimensional printing technology in manufacturing has become extremely popular as 3D printers become available to manufacturers. Evidence of this is seen across many major industries such as automotive, medical, sports, electronics, aerospace, and building materials. With the rise of 3D printing comes the increase in demand for materials that can be 3D printed. Hosokawa Custom Processing Services has the knowledge and equipment to process these materials for you. Materials that are used with three-dimensional printers usually need to be reduced in size to a fine powder and sometimes classified before they can be 3D printed. HCPS routinely processes materials such as nylon PA, polylactic acid PLA, ABS, thermoplastic polyurethane TPU, and PEEK, and many more. Current applications require sizes from 600 microns down to 50 microns. HCPS has a attrition milling system specifically designed to process these types of materials. They are high-speed attrition mills designed for the fine size reduction of plastics and polymers that do not respond well to impact milling. They are designed to pulverize heat-sensitive and soft materials without the use of cooling and allow for higher capacities without material degradation. Hammer and screen mills can be used for the pre-grinding, de-agglomeration, and medium-size reduction applications depending upon the design and operating parameters of the mill and system. High-speed hammer mills will typically produce products having a particle size of 75 microns or finer. A wide range of particle size distributions with defined top sizes can be produced with a hammer mill. Rotor speed, screen configuration, and the type of grinding elements provide for flexibility and producing many different end products. The system depicted here is how it is installed at HCPS. Air conveying the material through the mill and into a product collector is the most efficient way to process large quantities of material. Our hammer mill design consists of a rotor assembly with impact hammers that rotate inside a cylindrical housing. The upper chamber of the housing consists of a multiple deflector liner. Particles are accelerated into the liner by the impact force of the hammer. The impact breaks the particles into smaller particles, and the liner slows the peripheral velocity of the particle and deflects them back into the hammer path for further size reduction. Multiple grinding elements and screen sizes allow for the flexibility to produce a wide range of products. The bottom section of the housing contains a screen. The screen is used to control the size of the particles exiting the mill. Various screen types and hole sizes are used to change the final product particle size. Here are examples of fine chemicals and minerals that are processed on our high-speed hammer mills. From this list, you can see the variation in particle sizes that the hammer mill system is capable of producing. Air classifying mills are air-swept mechanical impact mills with a dynamic air classifier designed to grind materials down to a D97 of 20 microns, while producing a relatively narrow particle size distribution. These systems are suitable for grinding a wide range of materials with a Mohs hardness of up to 4. The principle of operation of these air classifying mills involves the mechanical impact of material by high-speed rotating hammers. Particles are air conveyed into the mill for size reduction, and the internal classification system of the mill retains the particles in the mill until they reach a defined top size, which is determined by the rotational speed of the classifier wheel. Properly sized material is then air conveyed to a product collector where the finished product is separated from the process airstream. The air classifier mill combines a mechanical impact mill and a dynamic classifier in one unit to produce the tightest particle size distributions. Air classifier mills offer many benefits, including the production of a material with a defined top size and particle size distribution. Product fineness is easily adjustable by means of the variable speed classifier wheel and the adjustment of the system airflow. Continuous discharge of properly sized material minimizes the production of fines and maintains a consistent particle size distribution. Large volumes of airflow provide for cooler grinding and for the processing of heat-sensitive materials. These types of milling systems are ideal for large volume continuous processing. Examples of the variety of materials these mills can process are shown here. Adjustment of airflow and classifier speed allow the attainment of many different particle sizes. In addition to the materials listed above, we have ground various polymers to 99% less than 75 microns, graphite to 90% less than 75 microns, and lithium carbonate to a D50 of between 5 and 8 microns, and a D90 of 12 microns. Let's look at some specific applications. Lithium compounds include lithium oxide and lithium carbonate for use in the production of ceramics and glass, lithium carbonate for the use in production of lithium-ion batteries, and lithium stearate for the use in the production of lubricants. Lithium compounds, namely lithium cobalt oxide and lithium iron phosphate used in battery applications, have specific particle size distribution requirements. HCPS has micro ACM milling systems to produce the specific particle size distribution required for use in high-performance lithium-ion batteries. Ultrafine lithium powders used in lithium-ion battery applications result in improved battery performance. Performance improvements include higher usable capacity, longer life cycles, faster charging rates, higher efficiency, consistent discharge rates, and size and weight advantages. HCPS can process lithium compounds to your exact specifications. Ground calcium carbonate is widely used as a filler in paper and plastics and as a filler in coatings and paints. It is also used in cement and is converted to quicklime calcium oxide and slaked lime calcium hydroxide for use in other applications. Ground calcium carbonate is slightly basic and can be used to neutralize combustion gases or increase the pH in water and soil. Pure calcium carbonate is a relatively soft mineral compound with a Mohs hardness of between 2.5 and 3. However, mined limestone may have a minor portion of abrasive impurities such as quartz or sand, which may require special protection of the milling system. HCPS offers processing services for the size reduction of calcium carbonate with ACM milling systems. These systems can produce calcium carbonate products from 150 microns down to a fineness of 20 microns. Fluidized bed jet mills are for the processing of various chemical and mineral materials. These systems are suitable for the ultrafine size reduction of materials with a Mohs hardness of up to 10. The principle of operation of these jet mills consists of compressed gas that is accelerated through a series of nozzles at extremely high velocities. Particles are drawn into the accelerated gas streams and are ground via interparticle collisions. In order to achieve ultrafine particle sizes down to a D95 of less than 10 microns, the mill is equipped with an internal dynamic air classifier that can be operated at varying speeds to alter end product fineness. Ground material is air conveyed to a product collector where the finished product is separated from the airstream. Here are some of the benefits of this type of mill that we consider when deciding whether to choose this technology for your application. These milling systems produce the finest particle size with the steepest particle size distributions. Materials that require minimal ferrous contamination, materials that are heat sensitive, or materials that are highly abrasive can be easily processed in the fluidized bed jet mill. Finally, operating costs are minimized as energy consumption is reduced as correctly sized particles exit the mill immediately. Here are some application examples for products that can be produced on our jet milling systems. Fluidized bed jet mills can handle a wide application range. Due to their operating principle, they can handle extremely abrasive materials as particles are impacted against each other and not against the internal components of the mill. Very heat-sensitive materials can be processed due to the rapid cooling of the grinding air as it expands in the grinding chamber. Soft and sticky materials can be processed as buildup is eliminated due to the particle-to-particle impact, not particle-to-grinding chamber impact. Materials requiring a high degree of brightness or purity can be processed in these mills as most contact with ferrous components are eliminated, or ceramic components can be used to minimize ferrous contamination almost altogether. Let's look at some specific applications. There are a variety of applications for industrial waxes, and each area of applications has its own specific requirement. In many applications, for example, for printing inks or coatings, wax must be ground to an extremely fine consistency. The milling systems at HCPS offer solutions for these special processing requirements. Important factors when processing waxes include the desired fineness and particle shape of the ground wax, and the temperature sensitivity of the respective wax. HCPS takes all these requirements into consideration when deciding on the best processing solution. Our jet milling systems offer the best solution for the size reduction of waxes, particularly when a D50 of less than 10 microns is required. Tungsten carbide is a very hard compound that is synthesized from tungsten metal and a carbon source. Its high hardness makes it ideal for cutting tools, surgical tools, wear abrasion protection, and other applications. In order to be formed into various shapes, the tungsten carbide is typically ground to a fine powder and then bound together with cobalt and or nickel. Hosokawa Custom Processing Services has jet milling systems for milling tungsten carbide into a fine powder. In summary, we'd like to know how we can be your partner in manufacturing. We have the equipment, capacity, and know-how to provide you with high-quality processing services. Please contact us to discuss your application, and you're welcome to come and visit our new facility in Goldsboro, North Carolina. We'd be very happy to meet with you there. This concludes our presentation today on size reduction. I hope you found the information today informative. Thank you for your participation, and we hope to be able to work with you on future projects. Please look for our future webinars on the other processing services we can provide. Thank you, and have a good day.